So in this lesson, we're going to take the up and down and right man, and we're going to see if we can get him to move. When he gets to the right side and gets stuck, which we saw in the last lesson, we add one of these guys here, and we run this. This guy's already stuck. This guy's going to move up and down and to the right, and then when he gets over there, he gets stuck. So that's what we're going to try and fix today. So what I'm going to do is I'm going to make another subclass, and we could just modify this one to become what we want, but I am leaving it like this so that I can go back and look at things. I'm going to make another subclass, and I'll call this one up and down and right man. But I'm going to call it up and down and right and back left man. So this will be up and down and right and back up man. And I'm going to use the same orange guy for all the up and down characters. So there he is. And what I'm going to do is I'm going to take the code from, I'll take the act routine, which begins and ends there, and I'll copy that, and I'll replace the act routine in here with the one we just had from. So if I were to create one up and down man from my up and down, right and back, or I could call him up and down, back and forth man, he doesn't do anything. He doesn't go back and forth. So let's pause that. Let's reset that. Let's go look at back and forth where we fixed that so that it didn't get stuck at the bottom. And let's talk about what we did there. Oops, I didn't want to do that. Let's open this up. And on back and forth, our solution was to add a variable called turn amount and make that 90. And replace turn amount here and here as well as here and here. And the reason we did that was because if we ever get, when we were going back and forth, if we ever got to the bottom, we wanted to change our turn amount to the opposite of what it was before. So instead of turning right, we would now turn left. And the same thing if we ever got to the top. So we're going to use the same exact kind of code, except we're going to be looking at the right side. Let me copy this, and we'll just modify it and close that out. So anytime we make a move, for instance here, we could be moving into the right wall. Actually, this is the height. So we could be moving to hit the bottom. And when we hit the bottom, that's when we would need to change or modify our turn amount. So let me paste that in here. And let's talk about how we're going to do this. Now, it's going to give us an error right away because we don't have a turn amount. So let's take care of that next. So I'm going to put an int up here called turn amount. And we're going to start that equal to 90. And just like we did in the other example, our back and forth man, instead of turning negative 90 here, we're going to turn negative turnabout. And the same thing here. So instead of turning negative 90, we'll turn negative turn amount. Okay, and then if the one we copied in here was looking at the y value, let me just go back. Let me close this for a second. And let's go back and look at what happens with our up and down and to the right man. Let's make one. And I'll put them over here so we can see what happens a little more quickly. So what happens is when he gets to the position here and he's moving, let me just pause it. And he's moving up and let's for a moment picture him over here. And as he's moving up, he's going to turn right again, and he can't go for any further right. And the same thing happens here. He's going to turn left again. So we're going to look for if the x value ever becomes greater than the width, the x value plus 10 ever becomes greater than the width, then we're going to swap our turn amount from positive 90 to negative 90. And that's what we want to do in here. So we're looking to see not if the y value, but if the x value. So I'm using the code I had from the back and forth, but now the x's in the, we're checking for x's. When we were checking for x's before, now we need to be checking for y's. And we're looking at not the height here, but the width. So we're looking to see if we ever hit the right wall. And the right place to check for it is any time we've just moved, turned 90 and moved, because that's moving us further and further to the right each time. So not only do we want to check to see if we've hit the wall on the right, or if the x value minus 10 is less than 0, that's checking to see if we've ever hit the wall on the left. And if that happens, we're going to change the turn amount to its opposite. And that's what we have there. We're going to do exactly that same thing. After, I'll paste that here. We'll do exactly the same thing down here. So if we get to the if we get to where our x value is greater than the, it says weight, it should say width. I'm not sure what's going on here. What am I doing? And width. So if we go further to the right than the width of the world, or we go further to the left than 0, we're going to change turn amount to the opposite. Well, we need to use, where we see a 90 here, we need to use turn amount in both these positions. Turn amount. And if we compile that and close that, and now we create one of these guys, we'll see what happens. So every time you place them, they face the right. So that's why the very first bit of code we put in was to make a 90-degree turn. So he turns 90 and he goes down first. He's moving to the right, and when he hits that wall, the turn amount becomes the opposite of what turn amount was before, and now he turns to go back. And then the same thing, when he becomes less than 0, he does the same thing coming back this way. So that's our lesson on up and down and back up man. Hopefully you follow that. Feel free to watch it, pause it, try to get your code to work. And that's our lesson. I'll see you next time.